By the end of this tutorial, you will learn how to create a complex Niagara system by stacking up multiple emitters to create each individual effect, like this: spiky rocks shooting off the ground, outburst rubbles, ground smoke, heat distortion material, and lightning bolts hitting the ground. You will also learn how to model the spiky rock mesh directly inside the engine without using external 3D software. I will also show you how to create a simple sub-UV texture for the lightning bolts using a free online tool called photopea.com. So if you don't have access to tools like Photoshop, you can still follow along and create your own texture. Then we will import a Mixamo character and animation and bring everything together into a cinematic sequence, looking at some camera settings, post-process volume adjustments to make everything into a presentable way that you can upload into your portfolio. For this project, I've used Unreal Engine 5.6, but you can follow along with any recent version of Unreal Engine. And before we begin, I just want to mention that this is not a complete beginner tutorial. I'm assuming you already have some knowledge of the engine and some basic understandings of material, sequencer, and Niagara. I will still go step by step through everything, but I will move fairly quickly so the tutorial doesn't become unnecessarily long. So if you're ready, grab a cup of coffee, take a seat, put your phone on silent, and let's begin. And here we are inside the launcher. I'm gonna create a new project, select games, and I'm gonna rename it to tutorial. Hit create. And before we begin, let's go to File, New Level, Basic, Create, and once again File and Save Current Level. I'm gonna rename it to Level 01 and save. Now in the content browser, I'm gonna create a maps folder where I'm gonna drop my level. And drag and drop our level 01. Just click OK. Okay, now we're all set. Now we can begin thinking about creating these rock formations that will come off the ground. I use this as a reference, and I also tried to find something for free online, but I wasn't able to find anything on the marketplace. So I decided to make it myself, and I think it's always a good exercise to not rely on ready-made assets. Head over to the modeling mode, and by the way, if that should be already enabled by default with the engine, but in case you don't find it, you need to go to edit plugins and find the modeling mode there and activate it, restart the engine and come back. In the create tab, take a cylinder and place it onto the ground, increase the radial slices up to 52, and you can leave everything else as default. And in the model tab, click on polygroup edit and select the top face. Give it a value of 0.2 on both X and Y axis and click accept. So we have our cone now, and if you go to the wireframe view, you will notice that at the moment we have not enough geometry to create the shape that we need. So the next thing, we have to add some triangles to this mesh. And the way we're going to do this is in the mesh tab. If you select remesh, it's gonna automatically give you 5,000 triangles. I'm gonna increase the count to 10,000 to have a bit more polygons to work with, and we can always reduce them later if there are too many. Click accept, and now if you look at our wireframe, now you can see that we have plenty of geometry to work with, so we can create the displaced organic shape that we're looking for. And to do that, in the displace tab, and it's gonna give you by default a Berlin noise. So I'm gonna reset all these values because I've tried this before. I'm gonna go back to default. That's what you're gonna get as soon as you go to the deform tab. Now this is quite extreme, so I'm gonna reduce the value on the Berlin noise from 10 down to 2, and as you can see here, it already gives us the impression of some rock formation. But we also have a lot of controls down here, and if you open all these drop down menus, you can control each individual layer of noise. You can go ahead and copy the values like mine, or you can play around with them and create your own unique shape. So here are the values if you want to pause the video and copy them. When you're done, click accept. And make sure you save. And now head over to the dynamic sculpt and decrease the size of the brush and try to fix the top there because it looks a little bit weird. Just try to give it an organic shape. And at the bottom as well, I'm gonna push this in a bit on the sides. I'm not gonna spend too much time on it, but this is my final result. And when you're done, click accept. Make sure you save again and go to the selection mode. Now we need a material for this, so head over to Fab and search for rock. Make sure you select free. I'm gonna use this one here, rock cliff. And I'm gonna go with medium quality. I really don't think we need high quality for this, but if your computer can handle it and you want to download high quality, you can do it. And I also want to show you another thing. If you think the poly count is way too high and you want to reduce it, just go back to the modeling mode. Go to the mesh tab and click simplify. I changed the simplifier type to UE standard and target percentage 25%. So we started with 10,000 polygons and now I'm taking it down to 2,500. And now it's time to apply the material. So go to the content browser, go to the Fab folder and find the material, drag and drop it onto the mesh. Now you may notice here a little bit of stretching going on, and this is because we have sculpted and modified the shape of this mesh, which means also the UV have been stretched. So to fix this, go to the modeling mode. In the UV tab, click on auto UV, and we can leave everything as default, as it looks fine as it is. So just click accept. And once again, make sure you save everything. And as a last thing before moving on, I want to show you another trick that lets you add an extra layer of details to the model. So if you go back to the modeling mode and then go to the form tab and then displace, you can change from Perlin noise over to texture 2D map. And that means that now you can use a texture to displace the model, rather than relying exclusively on faking the details with the normal map. So if you go back to where the material is, you will see another folder called textures. Inside the folder, there is a texture called ORN, and that stands for occlusion, roughness, and metallic. We can use the red channel, the occlusion, to displace the model. So drag and drop it into the slot and make sure the channel is set to red. And as you can see, it already worked and the details are all popping up. But a value of 10 is too much, so I'm gonna lower it down to 3 or 4. And as you can see now, there is real geometry in the model, rather than just faking it with the normal map. This is not necessary, you can skip this step if you want, but I just wanted to let you know about this. And now we need to create a texture for these lightning bolts. It's basically just a texture with a transparent background. I couldn't find one online for free, so I decided to quickly make myself one. If you have Photoshop, you can use that, but if you don't have access to it, you can use a free online tool called photopea.com, which is what I used. Once you open Photopea, create a new project, set the width and height to 1024 by 1024, choose transparent background and leave everything else as default, and then click create. Next, go to view, add guides, and we need to split the texture into 4 sections. Select percentage and enter the values of 25, 50 and 75. So this will divide the canvas into 4 equal areas. Now click on the rectangle select tool and select the first section. Then press B on your keyboard to switch to the brush tool. Reduce the size of the brush to about 8 pixels. Then click on the top of the section and then hold Shift and click at the bottom. This will create a straight line. After that, reduce the brush size to about 4 pixels and start adding some smaller branches coming off the main bolt. Try to give it an interesting shape. I didn't spend much time onto this, so it's definitely not the best lightning texture possible, but it's just good enough to demonstrate the process. If you already have a lightning sub-UV texture, you can of course use that one instead. I actually had one, but I'm not able to share it with you guys, unfortunately. So that's why I decided to show you how to create a simple version yourself. Once the shape is done, go to Filter, then Liquify. Use the larger brush to bend the main bolt slightly, and then the smaller brush for the side branches. When you're happy with it, click OK. Next, go to Filter, Distort, Ripple. Set it to medium and reduce the amount to somewhere around 80 to 100. Now your first lightning bolt is done. From here, just select the next section with the rectangle select tool and repeat the process. By the end, you should have something like this. Then finally go to File, Export, Export as a PNG and save it. And then you can just drag and drop the PNG file into the content browser or Real Engine and it will be automatically imported. And we can finally move to the interesting part, which is finally making our Niagara system. So go to the content browser, create a new folder and rename it Niagara. And then go inside the folder, right click, create a new Niagara system, type simple sprite burst and select, and rename the Niagara system to ns underscore ground destruction. Now double click to open it. Click on sprite render and press delete. We're gonna add a mesh render instead. Now here you can place the mesh that we just created. So go to the viewport, select the mesh, Control B to find it in the content browser, and just drag and drop it into the slot. Now we're gonna override the material. So add an element, and in the slot, we're gonna place the rock material that we downloaded from Fab. Now delete the spawn burst instantaneous and replace it with a spawn rate with a value of 10. Now everything is spawning in the same place, so we need to add a shape location module. And change the shape from sphere to box plane and select plane. Add the value of 540. So there is a little bit more of an offset. In the initialize particle module, increase the lifetime from 2 to 3. And change the mesh scale mode to random uniform with a minimum value of 0.4 and a maximum value of 1.2. So now we have some variation in the scale. In the particle spawn, add an initial mesh orientation. Enable the rotation and change the coordinates to local. Now convert this into a random range vector. Enter a value of 0 on Y and Z axis, and a value of 0.1 in the X axis. And change the orientation mode to system. Now we have a slight variation in the rotation of the meshes. To give the impression that the rocks are coming off the ground, we're gonna use a scale mesh size module. Convert this to vector from float, and then convert the value to float from curve. Click on the first key and give it a value of 0 at 0 seconds. Then right click, add another key, and at 0.1 seconds, give it a value of 1. Then click on the last key and enter a value of 1 at 1 seconds. Now click on the module, press F2 to rename it. I'm gonna rename it to Big Rocks. Now Ctrl D to duplicate so we can create the other row on the other side. In the initialize particle, enable the position offset and enter a value of 300 on the y-axis. In the initial mesh orientation, change the X value from 0.1 to minus 0.1, so now the rocks are leaning towards the opposite side. At the moment they will be sitting slightly above the ground, so go back to the initialize particle in the position offset, enter a values of minus 20 on the Z-axis for both modules. To better visualize what's going on, I can place the Niagara system in the level. It's looking good, so we can save everything and continue. Now we can create these outburst rocks, and to do this we have to go head over to Fab to download a couple of meshes. So open the content browser and go to the Fab icon and search for rock. Make sure to only search for free items, and I am gonna download this one. And also this Icelandic rock. Okay, now we can create a new module, add an emitter, and simple sprite burst. Rename it to outburst rocks. Delete the sprite render and add a mesh render. And in here we can place our rock. Delete the spawn burst instantaneous and add a spawn rate. And convert this to random range float. Gonna enter a value of 65 and 85. We cannot see anything because this rock that we downloaded is absolutely massive and we need to scale it down. So just to give us in perspective, that's how big this is. I didn't know this before downloading it, I just found out. So we have two choices, either change the mesh or go into the modeling mode and go to the Xform tab. And there at the bottom we can enter a value of 0.005 and complete. And now you can see the rock is there. So let's add the spawn location and change to box plane and plane. And I think the default value here for the size is fine. So let's go to an initialize particle, random range float, and let's give it a value of 1 and 2 for minimum and maximum. And the mesh scale mode, we're gonna set it to random uniform, and we can set it to 0.1 and 0.3. We might change this later. Let's add an initial mesh orientation module and we can leave it as random. Then an add velocity module, and we're gonna change the velocity mode to in cone. And for the speed, we're gonna use a random range float with a value of 300 for the minimum and 500 for maximum. The cone axis, we can do -1 on the X axis and 5 on the Z axis. Now they're all shooting up because there is no gravity, so we can add a gravity force and we can leave that as default as well. Now let's add a collision module, and let's decrease the restitution value down to 0.3. This determines how bouncy the rocks are going to be. In the initialized particle, I'm going to increase the lifetime minimum to 1.5 and maximum to 3. And I'm going to add a scale mesh size. And I'll change this to vector from float. And I'll change the value to float from curve. And I'm going to use this smooth curve. Then I'm going to add a drag module and save everything. Let's watch it. Okay, I can see already that there is some problem with the collision that we're going to fix soon. But I'm gonna create a level sequence so we can visualize everything better, and I'm gonna create a new folder for it. Hit save. Now drag and drop the Niagara system inside the sequencer and add a Niagara component track. Then hit the plus icon and add a Niagara system life cycle and change it to desired age. I'm also going to add a transform track, and I'm going to keyframe the first position. I'm going to convert it to linear, and I'm going to move to the end of the sequence, move the Niagara system forward, and keyframe the second position. There you go. You might have noticed that the rocks are not colliding with the floor, and this is happening because if you scrub the timeline manually, the collision doesn't work, but if you press play, it will work. I think the rocks are still too big, so I'm going to decrease the size even more to 0.05 for the minimum and 0.15 for the maximum. And they look a lot better. If you notice that the rocks don't collide properly with the floor and they sort of remain floating above, just reduce the particle radius scale to 0.1, and that's going to be much more accurate. And I'm gonna increase this to 0.2 and 0.08 for the minimum. These are going to be my final values for the size. The spawn rate, we can increase it as well to 100 for the minimum and 150 for the maximum. Let's watch it playing. Perfect. I'm going to increase the spawn location a bit as well from 200 and 200. And I'm going to add a second mesh renderer, and I'm going to choose the Icelandic rock as a second mesh. Let's watch it again. I think we can also decrease the minimum velocity, so 300 and 600 looks better. Save everything. And now Control D to duplicate the module, so we can add the rocks for the other side as well. And in the initialized particle, in the position offset, insert a value of 300 in the y-axis. So now we have the rocks on the other side too. Now in the spawn rate, I'm going to increase the spawn number to 150 and 200 for both modules. And I'm going to go back to the big rocks module, and in the initialized particles, I'm going to increase the lifetime up to 6 for both modules again, so they don't disappear so soon. And I'm gonna do the same for the outburst rocks. So in the initialized particle, the minimum value I'll enter 3 and the maximum 4. and for this one too. Let's watch it one more time. And in the scale mesh size of the big rock module, let's push back this key, and for this other module too. So the rocks are going to pop up a lot faster from the ground. Okay, now we will add 2 more modules to the Niagara system to create the lightning bolts, both the big ones and the small ones. So in the content browser, right click and create a new folder and call it materials, because we now have to create a sub-UV material. So right click, create a new material and rename it m_sub-UV. Open the material and change the blend mode to additive and the shading model to unlit. Now right click and search for texture sample. In the content browser, go to the texture folder, find the texture and populate the empty slot. Now add a particle color node. This is basically a bridge that connects the material to the Niagara system. So see it as a dynamic inputs that the Niagara system can drive in real time. So add 2 multiply nodes and connect the alpha channels of both nodes to one multiply and the RGB channels of both nodes to the other multiply, like so. Now right click and search for depth fade. This node is used to smoothly fade a material based on how close it is to another surface and avoid harsh intersections. Connect it to the opacity pin and then connect the other multiply node to the emissive color. And let's preview this on a plane, and as you can see, we have an issue. The edges are clearly visible, and if we use it as it is in the Niagara system, it's going to be very obvious. So to hide the seam, we're going to use a generate band node. And if I preview the node to show you, the black part is basically where the texture is going to be faded. But we don't want to fade that much, so I'm going to add a scalar parameter to control the width. And I'm going to rename it to bandwidth and connect it to the width socket. And enter a value of 0.5. And because not every material will need this, I'm gonna add a static switch parameter so we can control when to use this. I'm gonna rename it use band to hide seam. Connect it to the generate band node, add a constant and set it to 1. Connect to the false pin. Now add another multiply node, connect this to the B socket and the A socket from the other multiply node, and then into the opacity pin of the depth fade node. Now the material is complete. Let's stop previewing this node and let's activate the switch. And now you can see that the top and the bottom are faded. Let's deactivate it and apply. This. Find the material in the content browser, right click and create an instance, and change the prefix from M to NI, which stands for material instance. Preview it on a plane, and let's try the switch, see if it works, and it does. In the Niagara editor, add a new emitter and simple sprite burst as usual. Click on the sprite render and go to the material instance and put it into the material slot. Delete the spawn burst instantaneous and add the spawn rate. Enter a value of 7 to start with. In the initialize particle, convert this to a random range float and enter a value of 0.1 and 0.2. Convert this to random range color, and the first slot we can give it a bluish color with a value of 10 to make it brighter. And for the second slot we can give it a slightly darker color and a value of 3. In the sprite render, go to the sub-UV And for this to be displayed correctly, now we have to enter a value of 4 by 1. What I mean is we have 4 lightning bolts on the horizontal axis and only 1 on the vertical axis. If we leave it at a value of 1 by 1, we're going to see all lightning bolts at the same time. In the initialize particle, change the sprite size mode to non-uniform, and you can copy my values or enter your own values as you prefer. Now it's spawning right at the center of our system, so we need to give it an offset on the z-axis of about 400. And I will reduce the size down to 800 here. Now let's add a sub-UV animation module and select the sprite render. And if you press play, you will see that the sub-UV animation is playing correctly. And to scatter this around a little bit more, we are going to use a shape location module and set it to box plane and plane. Is the value of 470 and 700. In the particle update, I'm also adding a curl noise force, and I'll convert this into random range float. And I'll give a minimum value of 80, a maximum of 100, and noise frequency 10. Increase the spawn rate up to 10. Save everything. Now, lightning bolts are supposed to give off light, so I'm gonna put a light renderer here. Use this wisely, as it might be expensive on your system. The best way to deal with this, because it's very dependent on the kind of environment you're using that in, is to crank up the values to some extreme numbers and work your way down until you find something that you're happy with. And there is no right or wrong here, so I encourage you to play with your own values. And I'm also going to offset this on the y-axis because I want to center these lightning bolts a little bit more. I'm gonna rename this to lightning big. I'll save everything and Ctrl D to duplicate the emitter. With this emitter, we're going to create these small lightning bolts on the sides. In the spawn rate, convert this to random range float and give it a value of 100 and 200. In the initialize particle, reset the values of the offset, and I'm gonna enter a value of -170 and 40. And also the scale size, I'll reduce it to 20 and 30. And in the shape location, I'll choose box and I use 600, 170 and 300. And then in the light renderer, just play with the values and see what works best for you. I'm also going to change the size to random non-uniform, and I'll enter the values of 10, 20, 30 and 50. We should give this a random rotation. Let's watch it once more. Looks okay, so we can save everything. And I didn't plan this in the beginning, but then I thought it would be cool if these lightning strikes will generate some sort of heat distortion when they hit the ground. So for this we can create a new material in the master material folder and rename it m_heat distortion. By the way, you can also find a heat distortion material in the starter content if you don't want to create one yourself. But I'm going to show you how to make one anyway, because I'm also using a slightly different approach, trying to use an alpha texture to hide the seam. By the way, if you are using Unreal Engine 5.7, If you want to follow exactly what I do in the tutorial, you will have to revert back to the legacy materials. Area 5.7 is using Substrate, which handles things a little bit differently. I didn't want to add extra complexity. So in the project settings, if you type Substrate and disable this box, then restart the engine, you will be able to follow along. And another thing, if you go to the content browser and click the add icon and add feature and content pack, you will notice that you no longer have the starter content. So if you want to use the heat distortion material in the starter content, you will need to import that one from an older version of Unreal. And last but not least, if you are working in low scalability settings, make sure for this next part you go to at least high or epic, otherwise you won't be able to see the distortion. In the material graph, change the blend mode to translucent and the shading model to unlit. Now search for refraction and enable the index of refraction. Now add a constant node connected to the refraction socket and give it a value of 1.33. Add another constant connected to the opacity and leave it at 0. Now bring in a texture sample and connect it to the normal socket. Click on this and search for water and select this T_water normal. Let's preview it on a plane. Now we have to make this texture move. We're gonna do this with a partner node. So right click and search for partner and connect this to the UV socket. Now search for a constant free vector. And also bring in a lerp interpolate node. Connect these two to the A and B sockets and the output to the normal. Now bring in another texture sample. Click here and search for alpha. Now this is not really the best texture, I'm only using whatever is available by default in the engine. So if you happen to have a fire alpha texture, it will work better. This is good enough to break the perfectly straight edges of the texture. Now add the power node. This is going to control the contrast. Right-click and search for constant for vector. This node alone is going to control all the parameters. So right-click and convert this to parameter and call it distortion settings. Down here, we can rename each channel. So the red one is going to be speed X, the green one speed Y, and then we have mask contrast and refraction rate. Now we need to combine speed X and speed Y into a single pin, and we can use a make float too. Connect it into the speed, and now connect the mask contrast to the power node. Also double click to add a reroute node and bring it down there. And connect this one to the refraction. Save all. Now click on this parameter and let's give some default values. So we can leave the speed X at 0 and speed Y at 0.1, mask contrast 1.3, and refraction rate 1.33. Now in the content browser, right click and create a material instance, rename it to mi_heat distortion, and take it off the master materials folder. Now open the Niagara system and add another emitter, a simple sprite burst as usual. Now click on the sprite renderer and change the material to the heat distortion. Delete the simple sprite burst and add the spawn rate. I'll start with a value of 10. Then add a shape location and change this from a sphere over to a box. Initialize particle, I'm gonna change the uniform sprite size to something like 100. And I'm gonna change the spawn rate to random range float, and with values between 20 and 45. I'm gonna keep on increasing the size until we start seeing something. Okay, maybe this is too big. I'm gonna change the lifetime as well to a random range float, and with the values of 1 and 1.5. And I'm also gonna add some offset so it's more centered. Let's reduce the lifetime as well, 0.5 and 1 should work. And I'm also going to convert this to a random range float, and with values from 150 to 250. Okay, I'm gonna change the values of the shape location as well. I think 200, 450 should be good. And the initialized particle, I'm going to increase the sprite size even more, 250 and 350. And I'm also going to add an offset of -20 on the z-axis, so they're closer to the ground. Okay, I'm gonna change this again to 300, and the spawn rate, maybe I want more, maybe 35 and 55. And I'm also gonna add a random rotation. Now we can create a material instance for the ground smoke, but before, let's go back to the master material and convert this to a parameter so we can change it in the material instance. Save. Make a duplicate of this instance, open it, and tick that box, and we can change the texture to this T_smoke sub-UV 8x8. Now duplicate this emitter and rename this one to heat distortion and the new one to ground smoke. Click on sprite render, assign the new material instance, and go to sub-UV. We have a 8x8 grid, so we're gonna enter 8 in both slots. Add a sub-UV animation module and select the sprite render. In the initialized particle, I'm also gonna change the color and reduce the value to decrease the intensity of the smoke. Now add an add velocity module, and we can leave it as default, so the smoke slowly raises over time. And I think the smoke is still a little bit too intense, so I'm gonna reduce its value. And yes, something like that would work better. I also want the smoke to last a little bit longer, and I'm going to increase the minimum and maximum value of the lifetime. Save everything. And now we finished with our effect. So now we can go ahead and bring a cinema camera actor and start working on the sequence. Drag and drop the cinema camera actor in the sequencer and change the frame per second to 24. Now add the post-process volume. And in the detail panel, type infinite and tick this box. This will make sure that the post-process volume has an effect on the entire world. Then search for the exposure and change it to manual, and then increase it to something around 11.5. I also noticed that the rocks are not colliding properly with the floor, so in the module, just go to the collision and reduce the particle radius scale to 0.1 for both modules of the outburst rocks. And now this is much more accurate, they're actually touching the floor. Save everything and select the camera. In the detail panel, search for crop and set the crop settings to 239. Now search for squeeze factor and put it all the way up to 2. This is going to make everything more cinematic. So back into sequencer, if you expand the transform and expand the rotation, you can right click on roll and pitch and override them with parallel noise. This is a fast and quick way to add a camera shake. And you can control the frequency and intensity from this menu. If you right click on the track and go to parallel noise channels, you have access to both of them here. Now we can get our character from mixamo.com. If you don't have an account, you might have to create one before you can actually use it. I'm gonna search for attack animations. I'm going to get this one here. Now I'm gonna have to choose the character, so go to the character tab and I'm gonna search for this brute. Download, and I'm gonna select 24 FPS and I leave everything as default. Back into a reel in the content browser, create a new folder and call it character. Go inside the folder, hit the import button and go to the file and import it. In the import window, scroll down to where the skeleton section is, type SK and find the skeleton to assign. Now it's gonna throw a bunch of errors, just click yes and continue and it will work anyway. Now drag and drop the character into the viewport and then bring it inside sequencer as well. Now hit the plus icon and go to animation and select the animation. Now if you scrub through the timeline, you can see that the animation is playing. Now it's all about positioning the character in the right place. Basically, when the character touches the floor after the jump, it should correspond to where the Niagara begins. Now to match the two animations, I'm gonna move forward this Niagara track to delay it until the character touches the floor. And I'll delete these cameras from sequencer along with the tracks. So I'll start over if you want to follow along, so you see exactly what I'm doing. So I'm just double checking that everything matches correctly here. And this starts exactly when it's supposed to start. Now I still have my cameras in the outlier, so I'll just drag and drop them again inside the sequencer. Now for the first camera, I don't want any camera shake. I only want to keyframe the position. So I'm gonna place the camera in the first position and I'll keyframe it. I'm also going to convert this on this keyframe to linear. If you right click on it, you can convert it. And then I'm gonna move to the end of the sequence. I move the camera to a second position and I'll keyframe it. And that's our movement. Also, I want to change the camera in the moment that the character hits the floor. So I'm gonna move the keyframe back to about here. And I'll keyframe again just in case. I'm also going to push this back. So in that place is the camera cut where the second camera will kick in. So that's the second camera, and we can move it to a position maybe not right in front of it, maybe a little bit on the side like this. And I'm gonna keyframe the position, and in the transform we can do the override again. So in the roll, right click, override with double parallel noise, same thing for the pitch. And now you have your shake. Now we can add the second camera track, so click the plus icon there and select the camera 2. If you click the top icon and start from the beginning, you should have this. I think the first camera is moving a little bit too much. Maybe I want it to go slower. So the second position, I'm gonna move it here and keyframe again. Yeah, that's much better. And with this we are done. That's everything for this tutorial. Thank you for taking the time to watch it, and I hope it gave you a better understanding on how to combine different Niagara systems to create a cinematic VFX in a real engine. I'll see you on the next one.